Hi viewers, welcome to my channel. Today we are going to learn a new lesson, that is acids, bases and salts. So let us start. First, here, what is the nature of this chemical? Is it acidic or neutral or basic? See, here what is a acid and what is a base? See, first, these acids and bases are exactly opposite contrast to each other. That means these acids and bases are opposite to each other. Here, if acid is positive, then base will be negative and neutral will be 0. Always neutral is 0. And you know that acid plus base gives 1 minute. See, acid plus base gives us salt. This is called as neutralization reaction. See, next, in my first slide, I said you that what is a acid and what is a base. Acid is sour in taste, a chemical which turns blue litmus to red. It is acidic, and this acid, when it is dissolved in water, then it releases H plus anions. See, to test a chemical whether it is acidic or basic, you have to test the taste, which is if the taste is sour. If it is sour in taste, then it is acidic in nature. If it is bitter in taste, then it is basic in nature. And if it turns blue litmus to red, then it is acid. And if it turns red litmus to blue, then it is a base. And here, if we dissolve that chemical, then if we dissolve that chemical in water, and after dissolving the chemical in water, if it releases H plus ions, then it is acid. But if it releases OH minus ions, then it is a base. See, example of acids are our curd, lemon, vinegar. And example of bases are baking soda, soap, and baking powder, etc. And we use detergents, that is also a base. Next, now here, aqueous solutions of acids and bases. Aqueous means dissolved in water. Here, this is acid means those chemical that forms H plus ions in their aqueous solution is acid. Like if we take HCl, and if you dissolve it in water, then you get H plus and Cl minus ion. See, here we are getting H plus ion. That means this is a acid. Next is H2SO4. H2SO4. And if you dissolve it in water, you get H plus and SO4 2 minus. H plus and SO4 2 minus. See, here also you are getting H plus, and that means this is also an acid. You can take so many examples. Here another example is HNO3. HNO3. If you dissolve it in water, then you get H plus ion and NO3 ion also. And here one thing. In first, I gave you an example of HCl. When you dissolve it in water, you will get H plus and Cl minus. H plus and Cl minus. Here, this H plus and gets dissolved in H2O and it becomes H3O. See, HCl if you dissolve in water, you will get H plus and Cl minus ions. And as you dissolve it in water, you will get H plus ions. You know, these H plus ions get dissolved in this water. Remain in water and it becomes H3O. It becomes H3O. Next, and now you can take examples like H2SCO3. 1 minute. H2CO3 and dissolve it in water. Again here you will get H plus and CO3 2 minus and next example is our H3PO4. H3PO4 and if you dissolve it in H2O you will get H plus and PO4 3 minus. Here one thing, in first I said you that I gave you example of HCl dissolving in water, H2SO4 dissolving in water and HNO3 dissolving in water. These three examples I gave you. See here, these three are strong acids. Strong acids means those acids which form more H plus ions in their aqueous solutions. Those are called strong acids. And I gave you another example of H2CO3 dissolving in water and H3PO4 dissolving in water. Here, these two are mild acids. Mild acid means those acids which form less H plus ions in their aqueous solution is called mild acid. That means if they dissolve in water, these two H2CO3 and H3PO4, if they dissolve in water, then they will release less H plus ions compared to HCl, which are strong acids. Compared to them, they will release less H plus ions. And next, we will see about bases. See, now here bases are those chemicals that form OH minus ions in their aqueous solution. Bases are those chemicals that form OH minus ions in their aqueous solution. See, like we can take NaOH, sodium hydride, NaOH. And if you dissolve it in water, then you will get Na plus and OH minus. See, here you are getting OH minus. That means it is a base. And next, KOH. And take KOH and dissolve it in water. Here you will get K plus and OH minus. Again here you are getting OH minus ions. That means this is also a base. And CaOH2 taken OH taken twice. Here and take it and dissolve it in water. And by dissolving in water you get Ca2 plus 1 minute Ca2 plus and you get OH minus. That means this is also a is also a base because it is also releasing OH minus ions in its aqueous solution. Next, we can take magnesium hydride Mg and MgOH taken twice and dissolve it in water, and by dissolving you get Mg2 plus and OH minus. Here, then you are getting OH minus ion. That means this is also a base. Next, now we will see some naturally occurring acids. See, another thing I have to tell you that here in bases also there are two types. One is strong base, one is mild base. Strong base is those base which form more OH minus ions in their aqueous solution, and mild base is a base which forms less OH minus ions in its aqueous solution. Now we will see some naturally occurring acids like vinegar. Vinegar contains acetic acid. Orange contains citric acid. Tamarind contains tartaric acid. Tomato contains oxalic acid. Sour milk contains or curd contains lactic acid. Lemon contains citric acid. See, orange and lemon both contain citric acid. And steamed that also contains methanoic acid. Nettle string also contains methanoic acid. And another still you can take like apple contains malic acid and grapes contains gibberellic acid, etc. There are so many naturally occurring acids. Next, now what is a alkali? An alkali, a minute here. All bases do not dissolve in water. See, there are so many bases which do not dissolve in water, but an alkali is an base that dissolves in water. If any base is dissolved in water, then it is an alkali, and this alkali is soapy to touch, it is bitter in taste, and it is also corrosive. But never touch such chemicals or taste them as they may cause harm. Here, example are sodium hydroxide, which is NaOH, and here another example is potassium hydroxide, which is JOH. Next, another example is calcium hydroxide, CaOH2, CaOH taken twice.